Yes, dear students, our text topic is alternating current with a inductor. In ideal case, we take inductor as resistanceless, but actually there would be some resistance in the turns of the coil. Let us start in ideal case. There is a source voltage. There is source voltage. E is equal to E naught sin omega t. We have to find the current when the source voltage is this one. We know this is a sinusoidal. This is a varying voltage with magnitude and directions. So a EMF is generated across the coil of this inductor. That EMF will be minus L di upon dt. We already know by the Kirchhoff's loop law. By Kirchhoff's loop law, the total voltage across the circuit elements, I mean that the sum of the voltage across the circuit elements would be 0. Here voltage across the source is E and across the inductor is minus L di upon dt, and their sum becomes 0. From here, if I calculate E minus L di upon dt becomes 0. From here, L di upon dt will be EMF, which are the value E naught sin omega t. Now from here we can calculate the time rate of the current, which is E naught divided by L sin omega t. So this is the slope of the current with time. The slope of the current with the time is the same phase with the source voltage, which is sin omega t. This is also sin omega t. So we can calculate the current from here with the help of the integration. So from here di is equal to E naught divided by L sin omega t dt. If I integrate this one with respect to the time, so I will be able to find the current. Now the current becomes now integrate of current, integrate of E naught upon L sin omega t dt. It comes out, integration of sin omega t becomes minus cos omega t divided by the coefficient of t, which is omega, minus E naught omega L cos omega t, and then left hand side I got the value of I. Now from the trigonometry we know that sin 90 minus theta v omega t. From here, taken minus outside of this sine function, it becomes minus sin omega t minus 90 is equal to cos omega t. If I replace cos omega t by this value, I got the current E naught omega L, minus already is there, and if I replace cos omega t by minus sine times omega t minus pi by 2, it becomes Now after simple calculation it becomes and by the Ohm's law voltage divided by resistance will be the current. Now these terms represent maximum current. Therefore the maximum current here or maximum amplitude would be sine omega t minus 90. So from the Ohm's law sine omega t minus 90, this terms I have the maximum value plus 1. If this has the maximum value plus 1, then I have the maximum value I naught, which is E naught upon omega. And from the Ohm's law, omega represents inductive reactance. Inductive reactance we represent is generally XL. XL has the same dimension as that of the ohms. So that's why XL's the same property which opposes the current, change of current in this circuit, as the resistance opposes the change of current in the circuit which contains only the resistance. So here this XL known as, so which value is omega? Omega angular frequency, L is the inductance known as inductive reactance. So here if I see the value of AC source voltage, which is E naught sine omega t. Here the phase angle is omega t, here the phase angle is omega t minus 90. Omega t and omega t minus 90 for comparing the AC voltage and the current which is passing through this circuit. So we have to make the omega t coefficient of omega t is positive. Omega t is positive, only then you can compare. So here omega t is the phase angles, here omega t minus 90, here the phase angle is omega t. So here I can say that the voltage lead by an angle of pi by 2. I can say that current lagging behind the voltage by an angle of pi by 2. So we can say in this way, current lagging the AC voltage by an angle of 90. So this is the phase difference between current and voltage when there is only inductor in the circuit. Our next part of this inductors is how to represent these circuits, how to analyze this with the help of the phasor diagram. We already know that there is a phasor vector. This is the phasor vector voltage V, and this is the current vector I, and their projection. This is your x-axis, this is y-axis. The projection of voltage along the y-axis will be the instantaneous value at the time of t. So it means that at the time of t, the voltage across the source becomes this one. Now make an angle omega t. We already know that omega is equal to theta divided by t, and from here the angle theta which is traced by the voltage is omega t. So now we already know that voltage across the source is E naught sine omega t, and the current which produced across the inductors at the time of t is equal to I naught sine omega t minus 90. So here you will see that the current is lagging behind the voltage by an angle 90. So that's why the current is rotating anti-clockwise. If the voltage, normally always the angle should be made from the positive direction of x-axis. Here voltage vector this one, and their source voltage is making an angle omega t with x-axis, and the current is lagging behind by the voltage by an angle of 90. That's why the current voltage, the current vectors is behind the voltage vector by a angles of 90 degree. So their projection, the projection of the current on vertical directions, your y-axis will be their instantaneous value. This is the instantaneous current in the circuit, which is I naught sine omega t minus pi by 2. So in this way we can analyze and the complex circuits in different elements very easily with the help of the phasor diagram. Now next part we have how the power consumed across the inductor. Now the power consumption in inductor. The instantaneous power supplied to the inductor is PL is equal to, we know that voltage into current. This is the formula. Put the value of source voltage E naught sine omega t and the value of I naught sine omega t minus pi by 2. So some simple calculation, it becomes E naught I naught sine omega t. So if I taken minus outside of this sign, it becomes sine 90 minus theta, 90 minus omega t minus outside, because sine minus theta, sine minus theta has the value minus sine theta, and sine 90 minus theta becomes cos theta. This is for bio students. Now finally it becomes E naught I naught sine omega t, and this becomes cos omega t. Using the formula of the trigonometry, if I divide by 2 and multiply by 2, this quantity becomes sine omega t minus E naught I naught divided by 2 into sine omega t. So if I calculate the value of over one complete cycle, calculating the average one complete cycle, the power comes out 0, because the average value of sine omega t in one complete cycles is 0. So this is the sine function. This is one complete cycle. First half is positive, second half is negative. So power consumption first cycle is positive. Positive means the power supplied by the source. In second half cycle, power is taken back to the source. In first half, power is given by the source to the inductor. In second half, this is value negative. It means that power is returned back to the source by the inductor. So in this way, net power or net consumption by the inductors would be 0. So now the average power becomes average power consumption in one complete cycle is equal to, average has the symbol this one. Either you take bar over the PL. So it comes out minus E naught I naught and average of the value of sine 2 omega t as I have already discussed it, how sine 2 omega t becomes 0 mathematically. So this power consumption comes out 0. So there is no power consumption, there is inductor in the circuit. I would like to explain again this. This is instantaneous power loss, yeah, power consumed across this inductor. So we have to find out the average value. Average power loss represented by this and this. So it becomes now I naught E naught by T is the constant terms taken outside the bracket. We have taken only the average of the functions which includes the time, varying time. So here it has the value sine 2 omega t. So if I draw the graph of sine 2 omega t, it comes out this is the sine 2 omega t function. Sine 2 omega t function, half cycle is positive, second half cycle is negative. In power consumption across the inductor, yeah, through the inductor, first half positive, it means that power is supplied by the source to the inductor. Second half, power returned back, power returned by this, power returned back by this inductor to the source. So in this way, no power is lost across the inductor. So the average power loss through sine to omega t becomes 0. We already discussed in last part how to calculate mathematically this value. Average this value comes out 0. So the total power loss across the inductor in this way becomes 0. Now let us discuss the graph of voltage and current versus omega t. In last part I have found the current with relation of the voltage. So this is current, this is voltage, and origin, phase angle phi, and this is 2 pi. So we know that voltage cross, this is voltage, your voltage, and this is your current I. Voltage cross the positive half, voltage cross the half, yeah, origin first time by an angle of 90. This is pi by 2. Earlier than that of the current crossing the origin, yeah, right half of the origin after an angle of pi by 2. So that's why this phase angles, this will represent already. So the phase angle is omega t minus pi by 2. So whenever current is 0 and voltage is maximum, okay, and when the voltage is 0, current is maximum. When the current is 0, voltage is maximum in negative half. Same way, when the current is maximum in negative half, the voltage becomes 0.